Okay, this is the second of a set of videos here where I'm going to do the wrench problem. And what we see here, of course, if I have a box around I don't really want, I'm going to pick up on one thing I forgot to do, which is at some point after I drafted that box, I should have said -V for view, window, plot view is, we're going to use one view. It's going to be called plot view. I'm going to go from the endpoint there to the endpoint there. I'll point out that that combined with then this idea of layer states manager, all state or plot view state, those are going to be really important things. All right, based on some great student feedback, and we'll come back to the Yogi one more time vis-a-vis Randy. You can all thank him for that one. All right, what we have here is we know that we have a circle here that, and the circle's defined, its midpoint is defined by that point there. So we're going to go ahead and draft now the Ogi, just without doing these, pushing the middle of the middle, or cutting it in half and a half again. This actually is not a bad way. It's actually a little less drafting. So we're going to go from the midpoint of that line to the intersection, right? And we'll do the same thing here, drawing this time, ignoring the going up to the top because I don't need the tangent radius. I'm going to go from the intersection here, from the midpoint in this case to the intersection. And you'll notice sometimes now with these dotted lines, they can sometimes be a little bit of a pain, but now we can trim both our circles to this line, which is pretty nice. And we have the Ogi defined. That's a big part of this. And we'll leave the center lines around, but once again, perhaps these center lines here are in our way. We'll take them, and now we'll change their property to hidden again. But we'll use the hidden, right, for something else later. So you have your Ogi defined, you have your center. The next things might be here. You're going to go ahead and eventually do a polyline edit, but keep things in base entities for the short term. But we're going to now go ahead and define our ellipse. I'll just see if I can bring up the draw. There's your draw ellipse. You have a couple of different ones. Axis, center, and then arc. We're going to try axis ends. So axis endpoint, from shift right click the endpoint there, shift right click the endpoint there, and then shift right click the midpoint there. And you noticed in that kind of what you saw when you're doing the polygons. Sometimes it's not a bad idea to draft out these are called bounding boxes. You could have also done it by center ellipse. I'll do the same thing here, but if you remember having drafted those boxes, this will make it potentially easier or potentially harder. But it does feed you in a little bit to what's going to happen with other programs in terms of trying to approximate things. So I'm going to go axis end again. We've got our first axis end is going to be the midpoint up here and the midpoint here, and then off on one side to the midpoint, and you have your two ellipses defined now. If you remember in the end, a ways back, we got rid of a line, which I'll show you here. You can go from the quadrant of a ellipse as well to the quadrant of an ellipse. The 4 points defined by 0, 90, 180, 270, or 0 pi over 2 pi, 3/2 pi, and 2 pi, if you would. 0 and 2 pi are the same direction when you talk about radians. All right, this last one is a nice, interesting one, I have to say. This construction in terms of what is happening with the wrenches. So I'm going to do the right side first. It's an offset of 0.31, offset 0.31 on either side. And it doesn't give you a particular distance, but it gives you a radius. And so what you can now realize, there's this great idea of reversing, I guess. If a circle is the set of points equidistant from a point, if you need to find the center point on any arc, you just draw two circles from 2 points on that arc that are the same distance, head distance being the radius. Watch, it said that radius is 1.18. Therefore, now if I draw a circle radius from the intersection here at a distance of 1.18, and then I do the same, draw a circle, this time from this intersection at a distance of 1.18, I now have the circle I really want, which is going to be here, from the shift right click, the intersection here, and you could just say 1.18, but it's probably better drafting to go through the intersection. And then there you have it. You can now extend, or you can, I'm sorry, yeah, I'm out of time here. I'm going to trim, trimming here and here, and I'm going to extend, screw that, and at this point you probably don't need the bounding box anymore. Now the bounding box might start to confuse you, so you can put that on something called hidden. Again, that hidden layer is going to be used for something else in the future, so I really don't want to get you completely set in that. But now really you don't need these, and so you can trim these out, and in reality you've got, and you don't need the end of this ellipse. And I'll finish this out, not all the way because I don't want to go to the next minute, but I'm going to finish out one side here to show you and check whether in fact things are going to work out in terms of filleting ellipse. Some have had a good sense with it, some have not. So by doing, first I'll do this, I'll go ahead and grab each of these and change them to the right layer, which is the object layer. Getting you used to this. And now I'm going to offset 0.375, which is half of 0.75 here and here. I'm going to break my ellipse in a positive direction, and then I'm going to finally try the fillet radius 0.25 and see if that works. And it does. Sometimes. And so if we extend, screw that up, and now try fillet 0.25, see if that works this time. You do. You can see that the fillet command and tangent radius can sometimes be just a little problematic, but you can fillet an ellipse, though. Many of you I know had a hard time with that, and I tend to avoid ellipses, but they come at you all the time, but mostly because you've changed your projection. I'm going to offset now through, think about the endpoint there, take this one through the endpoint there. To show you once again, you can take that thing here, do the same thing here. We had offset 0.38, and I will take this in the last 10 minutes, do a final 10 minutes here to do the plotting and the conversion into SketchUp and Sketchy Physics on this. So, but for the most part now you've got most of this thing drafted. If you remember now, we can do a circle radius from the intersection here of 1.18. Interesting that those are the same. Same thing there from the intersection of here of 1.18, and then circle from the intersection. This of course looks very similar to the perpendicular bisector, which of course we all love from geometry, but there is a lot of geometry in this even when you got all these tools. So I don't know that you could do that another way in AutoCAD. I'm sure you could, but understanding that sometimes you go back to base geometry. I'm going to erase out here and here. I'm going to extend, screw that. I'm going to trim. This time I didn't say screw that, I did this here. And now I'm going to take this box, put it on the hidden layer. Right, again, that's not hidden. For most of us, we're going to be talking about hidden lines a little bit. I'll try to finish out the last fillets. Remember, we break things in a positive direction. Fillet radius 0.25. Again, it doesn't always work. Sometimes you need to extend your thing through. Screw that. Fillet radius 0.25. 0.25. All right, running out of time. Thanks for listening. We'll do one more of these.